Hi everybody, it's Mrs. Dunn. So what we're going to do today is talk about increasing, decreasing, and piecewise functions. So specifically what I want you to learn from this screencast is how to identify the intervals over which a function is increasing, decreasing, or constant. We're also going to learn how to find the maximum and minimums. And we're going to do that from a graph and using the graphing calculator. And lastly, we're going to graph everybody's favorite piecewise functions. Okay, so the first thing we're going to do is talk about this concept of increasing and decreasing. So look at this graph that's in front of you. So when is this function increasing or decreasing? So what we're talking about is you could imagine if you were walking on this graph, right? So if you were walking on this graph and you're walking on it from left to right. So if I'm walking on this graph, I am going uphill until I get to this point, and then I start to go downhill. So we are increasing from the beginning, which is negative infinity, until we get to -1. Notice that's an x value. And then we're going downhill or decreasing from -1 until I get to positive infinity. So this negative infinity and positive infinity are the x values. From when x is negative infinity until x is -1, we're increasing. And from when x is -1 until x is infinity, we are decreasing. Don't be confused and look at y values. We're using x values for these intervals, not y's. Okay, so looking at this same graph, this graph you can see has a maximum, and the maximum is this point. These are the coordinates of the maximum. Now, how we say this is we say there is a maximum of 5 at -1. So the maximum value is a y value. So the maximum here, this one doesn't have a minimum, but the maximum value is 5, and it occurs at -1. Look at another example. Here's a graph of an absolute value function. So you try to identify when this function is increasing and decreasing. So this function is increasing from when x is 2 until infinity, and decreasing from -infinity until 2. I got to stress again, look at those x values. Now, what about a maximum or a minimum? It obviously doesn't have a max, or you could say the max is positive infinity, but what is the minimum value? Well, the minimum is 0. Remember, that's the y value. And it occurs at the value of 2. That ordered pair is 2, 0. Okay, one last example here. So here's an example of a constant function. And the function is g of x is equal to 4. So this function isn't increasing and isn't decreasing. It is constant over the entire interval. So it is constant from -infinity until infinity. All right. The next thing I want you to do is I want you to pause this screencast and try to find out when this function is increasing, decreasing, or constant. Did you get these intervals? It is increasing from -infinity until we get to -8, and then it is increasing again from -3 until we get to -2. We use a union symbol to show that union of those two sections. So it's increasing over two intervals. It is decreasing only here from when x is -8 until x is -6. And then it is constant on two intervals from -6 to -3, and then again from -2 to infinity. Did you get those right? I hope so. If not, go back and look over these until you catch on. Okay. The next thing we're going to do is talk about finding the intervals of these crazy functions. So this isn't one that you could graph by hand, right? So you're going to have to graph this on your calculator. So let's do that. So we'll plug in the equation. And it's minus 0.2x squared minus 5x and minus 4. All right, so let's look at this graph. I'm just checking real quick to make sure I didn't make any mistakes typing that in. And look at this graph. Now, what's unique here, and the reason why I use this example, is you cannot find or cannot see the minimum here. And it's important that we change the window so that we can see that actual minimum value. And you can play around with it while you're doing your homework. You either follow the directions and use the window they give you, or play around with it and find a window that works for you. Remember, to change the window, you press this window button. So the window, so anyway, this was a graph showing you that that part is missing. So the window I want you to use is an x min of -10, an x max of +10, a y min of -30, and a y max of +20. I paused the video so that I could put these numbers in just to save some time. But as I was doing that, it occurred to me, I want to make sure you realize when you go to type -30 in there, make sure you use this negative sign. If you use a minus sign there, you're going to get an error message. Okay, so after you've put those values in for the x min, x max, y min, y max, now look at the graph. Now we have a nice pretty picture and we can actually see that max and the min. All right, so what I want to do now is I want to show you how to find those max and mins on your calculator. So what we're going to do first is we're going to find the maximum value. To find the maximum value, I'm going to show you how to get to this screen. So the maximum value is the maximum value is 4.13 and it occurs at -2.57. But I want to show you how to get to this screen. So what you need to do is access this menu item right here, which says Calc. So to get there, we're going to press second and the trace button. That pulls up the calculate menu. We're looking for the maximum, this red dot. So obviously the menu item we want is number 4. You can either type the number 4 or you can scroll down using the arrow buttons. Now, pay attention to what your calculator says. Your calculator says left bound ? So what it's telling you to do is get this blinking cursor to the left of this point. Remember, the point we want is right here. That's the maximum. So we need to get to the left of that point. So I'm going to use this arrow key until I am clearly to the left of that point. Not on top of it, not here, clearly to the left of it. So that looks pretty good. I'm to the left of it, and I press enter. Every time you see that left bound, make sure once you get to the left bound, you press enter. Now it's telling me right bound ? So now I need to get to the right of that point. So I'll get to the right of the point, clearly to the right, not on top of it, clearly to the right. Don't worry if your numbers don't match mine right here. That doesn't matter. Just make sure that your cursor is clearly to the right of that. Press enter. You're still not done because it says guess. You don't have the answer until it says maximum like it does over here, right? So press enter and then you get the maximum. So you see the maximum value is the y value and it occurs at this x value of -2.57. All right, let's do that again, but let's do that by finding the minimum. So we're going to go through this again. Second calc, we want the minimum, that's number 3. So we're going to get to the left. Remember, this is the minimum. So we need to get to the left of that point. That's close enough. We're clearly to the left of it. Press enter. Then get to the right of it. Make sure you know your left from your right, right? So now I'm to the left of it, I'm to the right of it, and then it says guess, and I press enter one more time. And remember that minimum value should be between these two lines that are drawn. So I'll press enter, and I have the minimum, and you can see it here. So the minimum is negative 15.50 rounded to the nearest hundredth place, and it occurs at 3.24, also rounded to the nearest hundredth. Okay, the next thing we need to do is talk about when this function is increasing or decreasing. See, we needed to know the max and the min to identify those intervals when the function is increasing, which is going to be here and here, and when it's decreasing, which is right here. So fill in these intervals and see if you're right. So did you get from negative infinity to negative 2.57, remember x values here, and 3.24 to infinity? Here's where x is equal to 3.24. And it's decreasing from negative 2.57 until we get to 3.24. Those are all x values. Also notice these are always parentheses. All right? Okay, next thing up is piecewise functions.